Hello, everyone, and welcome to the very first stream of the Green Deal stage today on this Thursday. So I am here with Teun, and Teun, you are the co-founder of BYOR, which is an acronym for Build Your Own Robot, right?
Yes,
And you
indeed.
create very easy to use electronics that aim to make it simple to create robots using scrap materials such as cardboard. So in your video, I even saw that it's so simple that even kids can do it. So maybe you could tell us a little bit more about how it works and what your goals are with this project. And then if the audience has any questions, they are free to use the live chat on YouTube, and there will be plenty of time for us to answer these questions together. So please take it away and welcome.
Yeah, thanks. Yeah, well, I prepared a small presentation to show exactly what the product does. And it's designed for kids, so it's really simple electronics indeed. Well, this is more the vision, the first slide, because it's all about creativity, technology, and sustainability. It all started from sustainability, where we try to make robots and all kinds of devices more sustainable, and especially towards children. So we try to, instead of changing behavior from adults to be more sustainable, we try to teach kids the right mindset straight away. What you need for that is super easy to use electronics, because kids need to be able to use it and needs to compete with all kinds of apps and other games that give a really quick success experience and then build from there. And also because of the sustainability aspect, we really want them to build with scrap material and arts and crafts materials to get really creative with it as well. The product is actually made to allow kids to design, build, and program their own thought-up robots, devices, or art pieces. So it's really easy to use, really versatile to use also. And yeah, then I'm going to explain the electronics a bit. So I'm hoping I can be on the big screen with my webcam. So I can already see a little monkey behind me. That's one of the builds that we have. But of course, as I explained, you can build from scrap. So you can build whatever you want. The electronics are really easy to use. It all starts with a brain. I'm going to put it over here. And as you can see, the brain has two parts. It has a blue part, which is an input part, and it has a green part, which is an output part. And we have little components that are either blue or green. The blue parts are always going to be a sensor, so we're going to experience something in the world. In this case, it's a distance sensor. And the green parts are always going to do something. So in this case, it's a servo motor. We also have different green parts and different blue parts. So we also have a light sensor, for example. To connect the parts, you need these cables. So these are just basic jack cables, which are really easy to use. You cannot put them in backwards or whatever. And then the only thing you need to really think about is put the blue part on the blue side and the green part on the green side. And then, of course, you need to power these devices. And we just use a regular power bank, and you can just recharge those all the time. So, for example, at this point, I'm having the distance sensor right here. I have a motor right here, and if I come closer to the distance sensor, the motor will go slower or faster according to how close I am to it. And I can also just take other parts. For example, I can switch the distance sensor to a knob. Now I will turn the knob and the motor will turn. And also on the other side, I can do the same thing. I can add an LED, for example, and when I turn the knob, I can decide how bright it will be. So that's just the basics of the system. You can attach several of these at the same time, these couples of input-output. And then the next phase is actually to build these things into cardboard, which is, or maybe even other materials, because there's just holes in it. So you can attach it to, for example, cardboard. In this case, we use a piercing pen. You can just use like a cocktail pick. You pierce a small hole, Then you take a split pen, which is something a lot of people haven't seen in a long time. But it's really easy to use. You just pierce it through the hole again, and then you fold it open, and you get an attached part. And in this way, you can build really easily from cardboard and other materials, all kinds of stuff you want. So yeah, that's a quick demo of the product. It's really really easy, and it's color coded. Yeah, and what you can see is here you can attach different parts together to create your own functionality, and then you build that functionality into cardboard to make your own robot device or art piece. We have 4 different inputs. There's a distance sensor, turning a rotary knob, I should say, a light sensor, a microphone, and then there's an LED for the output, a buzzer, a servo motor, and there's a stepper motor as well. So the servo motor goes back and forth, and the stepper motor goes all the way around, but faster and slower according to the signal it's receiving. Well, the whole thing is really built to build. If you look closely at the components, you can see that they have coating on it, and it's all with jack cables and jack plugs, so it's quite sturdy. And when you use it, you can use cardboard to build whatever you want. This example is always something that we see in workshops because we do a lot of workshops with that product. This is a room protector, so you can actually see when someone was in your room when you're not there. So in this case, you have a distance sensor and you have a servo motor, and it just drops a marble. If you place it on the right part of your room, you can actually detect that the door will open and someone was in your room. And if you make a little pop-up, a physical pop-up, then you can see later and maybe even how many people if you upgrade this, but normally you can see that someone was in your room. And this is one of the possibilities. So you can use scrap materials in all kinds of different ways. You can attach it to the motors in different ways. You can do whatever you want with it. So you actually have a lot of different possibilities. So for example, here you see some robots that we just made during a workshop that we do on events. You got your basic robot on the left, and you got like a wearable robot in the middle, and then you got a really small robot at the right side. So that's something that we do. And then there's also the possibility to use the microbit, which is a really, everybody knows it in the educational realm, I guess. And it's a really easy to use chip that allows kids to program. So it's really made for children to do their own programming. And we didn't make it, the BBC made it from England, so it's really well spread, like I said. But we do, our little brain actually connects straight to a microbit. So you can add a microbit to the brain, and at this point you can, the brain will be taken over by the microbit. So the microbit can read out all the sensors, and it can actually send a signal to all the outputs. And you are able to also use the buttons from the microbit and also use the LEDs from the microbit. And it's just a really easy way to literally expand your hardware and then expand, and then you can add your own software. So it's really adding a component to make it easier. Here I have an example of robots that are actually programmed. So these ones are just our promotional robots. They're human-sized, and they just do random stuff. So I programmed it to have its head move randomly, and also it's just waving around the arm to get the attention of people. And there's no sensors involved, so you don't have to use the sensors when you're programming. You can, of course, you can add logic to sensor input also. And then this is a new development that we did, and it's because we noticed that a lot of people, especially consumers, they just want to make something really quick and easy and make something look cool. So we added these, they're just pieces of paper. Basically, they're recycled paper, and you paste them onto cardboard, and then you cut out the shapes. So you can make your own building material. And that's also the monkey I have here, for example. This one is actually created from these papers. So it's a cool way, because what you can do is you can take old cardboard that has, for example, branding on it or pictures on it or something, and then just paste over that with with the pieces of paper that we have, and then you create something really cool with old cardboard. It looks way better and it's easier to build. So it's really to get people started, and it's a nice way to get started with the product. Here I have a small video. This is building the flashlights. Oh, it has some music in it that I probably can't cancel right now. Oh. Yeah, well, you start out with cutting the pieces. Normally I skip forward this a bit, but in this case I cannot for some reason. So what happens is at the end you get a little flashlight that you make from cardboard. I think I showed it a bit from this, and it's okay. I'll skip over the other video as well because it's really long. We also have expansions in the form of a solar set. So instead of the power bank, you can also use solar panels now, which is quite new. We launched it 2 weeks ago, I think. And then you can attach two solar sets together. Also, if you look at the solar sets, there are also the holes in it that we use for the split pens. So they're really easy to connect or make part of your own build, your own creation. All right, so that's really what the product is all about, and all the different things you can use it with. But we also we make it a lot for education. So our focus was a lot on education. I think it still is. So we have teaching aids, and we have lessons and screen support, assignment books, all of that stuff for education. So we have 5 lessons in the theme of design thinking. So we're really going to do the brainstorming. The kids are going to do brainstorming. They're going to do sketching. They're going to do make like technical drawings, and then they're going to build something. And at the end, they're going to present it, and then they're going to also do a reflection on it, or how the process went and stuff like that. And because it's really, really broad, so kids can think of whatever they want and build whatever they want, we just try to get the process clear for teachers. And then there's also the programming, which involves a little bit more of just teaching, because they really have to know what they're doing. They can't just go all creative like they can with the physical parts, because the physical parts are really easy. The programming really needs some more explaining. But they pick it up really quickly, and then they can make really cool stuff. I always show this slide because it shows how we approach education. All the way in the top is just what the teacher can basically just read out loud almost. It's a little bit more than that. But then below the red line, there's all the outcomes. Because, like I said, it's a very broad process, and it can go a lot of directions. So a lot of possible outcomes. And we don't want to scare teachers, because most of the time, they're used to just having one outcome is the right outcome and the other one is wrong. But here it isn't like that. Here you can build whatever you want, and it's really not as black and white. So what we do is we actually show them a possible outcome, and then we also add questions that they can ask to the children. So if children don't really give the right answers right away, then you can ask the right questions to make them come to the right answers themselves, which is better for the learning. Right, then we have just the different products that we have. Well, there's a Kickoff Kit, which has a small brain in it. I'll show it really quick. And also, it's really just for starters. I don't know if I can give it on screen. Yeah, it's like the smallest one, and we use it for kids from 6 and up. So you have one input and one output, and you can't do anything wrong with this one. And then we add also these papers, so you can make really quick, simple creations. And then it goes all the way to a full kit and a school kit, which has a lot of different parts. In the school kits even have 2 brains in it, and they have several power banks, and they have a lot of stuff in it. They always have the essentials, so an easy board, power cable, even a split pen, so you can start building. And then there's different kits for that. So we have the Kickoff Kit, which one input, one output, and then School Kit has a lot more. Like I said before, we also do a lot of services, so workshops. We do workshops at schools. We do workshops as on events. We do teacher training. We do team building exercises and design thinking training for businesses also. So because it's so easy to use, you can actually use it. You can do a whole design process in an afternoon, and there's actually a prototype. If you need to, and there's a physical prototype. If you need to do that with other electronics and you do it for a non-technical crowd, that's just not going to work. You have to explain, how to make. It's just too much explanation. This is just click, 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 and it works. So that allows for really cool training as well. Looks a little bit like this. We have different, like top left is kids from, I think they're 14 almost, 13, 14. And then here on the right, you see an event which is outside, which is for smaller children. And then in the bottom right corner, you see for adults. We also do the training. Yeah, this is a really cool one.
Ja, deze is goed hoor. Je goede man alleen dat ook. Nee.
Yeah, we call this team building. You actually build something around your team. So this is you build a robot suit. So every group will get the assignment to build a part of the suit. So one group will build the arms, one group will build the helmet, one group will build the chest plate, and then they all have to be interactive. In this case, we actually added a target group. So the suit should be for baristas. So it helps focus a little bit more, like, okay, what are we going to make interactive and why? I think that helmet is just to get the attention, and then the other parts are to maybe even stir the cup of coffee or just help hand out the coffee. They came up with all kinds of stuff, and it's, yeah, as you can tell, the people are really happy, and it's really a fun exercise. Yeah, and then we can use different themes in these trainings, and we can also add someone's own theme if they have like also for schools, if they have certain themes, we can just add them to the process. It's not really hard. And crazy as it might sound, the structure for every training from primary school to training business people is almost always the same. So we just use these basic steps. So we do brainstorming. And then we just introduce the BYOR. So we don't start with BYOR. Oh, we don't start with BYOR, we start with brainstorming, so they go really, really broad. So they're not limited to any technology, basically. You can think of whatever you want. And yeah, after that, we introduce BYOR to show, okay, you have to do it with these parts. So what are your best ideas to do with these parts? And they focus a little bit more. Then we make the design sketches, so they focus even more on where the stuff is going to be, where the components are going to be inside the product they want to make. And then we do building, so that's just mostly, it's half an hour to 1 hour build, and then you present at the end, which is a short pitch most of the time. Yeah, these are just some examples of stuff we have. So in the left part, you see it's also happened during workshops, and I wanted to show it because on the left part you see that there's actually a robot that can cut a banana, and we actually tried different knives to cut it, so that there's really user testing going on, or actually functional testing, like which knife is going to be the best to cut the banana properly. And in the middle, I think, is a really ingenious thing, because they made a little conveyor belt, and conveyor belt, the turning part is connected to a distance sensor, and the turning part is actually a gear. So it's not a full wheel part, but a gear. And the distance sensor is inside the teeth of the gear, I guess. And every time the gear comes by, the knife moves. So if you make the conveyor belt go faster, the knife will go faster as well. So it's connected to each other in a really smart way. You don't have to program anything. It's just the natural occurring behavior of this device. And then the one on the right shows a little game they made. So there are two wheels on it, and they're both driven by sound, so we have a sound sensor. And if you scream on both sides just as loud, it will go straight forward. If you scream on the one side a little bit louder, it will make a turn. Because if it gets more signal, in this case sound, the motor goes faster. So you get this little game in which you have to shout really loud, basically, and they like that. And this is one I want to show also to show the process a little bit. Here we said, okay, guys, you cannot have a target group that you know. So you have to have a target group that you don't know. And they said, I don't know anyone who is a fisherman at sea. So then they came up with this idea. It's an interactive fishing net throwing device. Every time the girl pinches her hand, she triggers the sensor and the blue net will fall out. So it's really easy to catch fish, I guess. All right, so that's a little bit what we do. So in different products, we do workshops, we do trainings, and we also make custom craft packs, which I didn't say in the presentation yet. But yeah, for some businesses, we make custom craft building packs that will, for example, incorporate their logo or something like that, something they want. It's we can do whatever in that regard. All right, so that's my presentation.
Right. Thanks a lot, Teun. I don't see any comments so far yet, but I do have some questions.
All right.
So I was wondering, first of all, what's the youngest you've seen? So the youngest child using your product, because it looks like it's super accessible, and some of the kids in your videos are honestly like really young. So how easy is it really to get started as a child?
Well, we always say you can start from 6 on up, and then 6. If you start at home, you need some help from a parent.
Right.
But we had some. At some point we distributed some of the kits to get some reviews. So we were in the paper once with a review and stuff like that. And he said, I really started with my kit, which is only 4.
Wow.
4 years old, and it went really well. So I guess it's also, of course, it's dependent on the kit, but in some cases it works from 4.
Right.
So it was really exciting, yeah.
I guess you can also scale up a little bit, right? So if you make it a bit more complex and involve programming, then all of a sudden it might even become difficult for teenagers, right?
Yeah, indeed. Yeah, it goes all the way to I think halfway to high school. So yeah, we use it. We don't just use it for like small kids, and especially when you go programming and you add all the steps of the design process, you can go all the way to adults.
Yeah. Well, what I really like about this is that it's not only a fun toy, right? So it's not only entertainment, but it's really teaching you at a very young age how to approach design work, actually, which is a skill that will last you the rest of your life, and which actually is something that I've only recently gotten into at university. So seeing this and getting this to people at a very young age, I think will massively improve the way they approach design challenges, and also really matches what current careers expect of you, or current companies expect of you, to be a creative problem solver. So that's really impressive. I really like it, and I kind of wish I had one when I was younger, because I had to start with an Arduino right away, which is a lot of programming, which I couldn't do. So this is an easier step.
Yeah, and also if you start with Arduino, it takes quite a long time before you feel that success moment, right?
Right.
You need to get the breadboard, you need to get all the little things, and then something goes wrong because of the. It's just that's why if you want to compete in like the children's realm, now they have an iPad and they touch the glass and it says you're awesome.
Yeah.
You know? And we have to make it like click click and it works, because otherwise they just lose interest, I guess.
That's the way it is. Okay.
Yeah,
well, thank you very much. If any viewer wants to get in touch with you, where can they reach you?
You can just go to BYOR.nl, or even BYORcraft.com for the English, BYORcraft, CRAFT. And you can also just email me at teun@byor.nl.
Right, like this. That's great. Then I think we'll wrap it up and move on to our next session, which will be for me on the joy of life, about making the streets interactive. So actually, maybe a little bit similar. You might even want to. and then I might see you there. Thanks a lot.
All right, thank you.
All right, bye.